Welcome to the Deep Dive, your shortcut to, well, truly understanding the world around you. Today we're embarking on a journey into one of Earth's most captivating climates, India. Just imagine this land where towering mountains, distant seas, they all seem to choreograph this dramatic weather dance, a dance that shapes the very pulse of life there. Our mission today, to unravel this living story. It's woven through incredible extremes, ancient words, and powerful global forces. We want to discover what makes India's climate so utterly unique.
It really is a fascinating journey. We're talking about a land that stretches from, scorching deserts to freezing peaks, from torrential rains to these bone-dry spells. And yet somehow it all holds together. We'll connect the dots today, try to uncover the secrets behind these really dramatic variations. What makes India's climate so powerful, and why does that word, monsoon, hold such profound, almost sacred meaning? Let's dive in.
Okay, so to really get a grip on India's incredible environment, we probably need to start with the basics, right? The fundamental building blocks. When we look at the core elements shaping any region's natural environment, what are we talking about?
Well, typically we look at three main things. The landforms themselves, mountains, plains. Then there's the drainage rivers, lakes, and of course the atmospheric conditions. They're the real foundations.
Right. And there's a key difference we need to make early on, isn't there, between weather and climate?
Absolutely crucial. We often talk about weather, which is really just the atmosphere's state right now, or maybe today, tomorrow, it's momentary. But climate, that's the grand narrative. It's the sum total of all those weather conditions, all their variations, observed over a large area and for a long period of time. We're talking more than 30 years.
30 years, okay.
Yeah.
That long view lets us see the real patterns, the true character of a place.
Exactly. It's the difference between a snapshot and the whole photo album.
So, if climate is the long story, what are the ingredients we actually feel and see day to day, the elements making up that story?
We're primarily looking at temperature, atmospheric pressure, and precipitation, rain, snow, hail. Now, things like ocean currents are hugely influential, powerful forces.
Big time.
Yeah, but they aren't considered elements themselves, more like invisible hands guiding the whole symphony.
Guiding the symphony, I like that. And in India, that symphony is almost entirely conducted by one word.
Monsoon. It's more than just, a weather term. It feels
Yeah.
like the heartbeat of the subcontinent. And the word itself, it's quite simple, really. It comes from the Arabic mosi,
Oh, see.
which just means season.
Season, how straightforward.
It is. And that beautifully simple origin really sets the stage for India's main climate type, the monsoon climate. You find it across South and Southeast Asia. It perfectly reflects that deep seasonal rhythm.
Okay, now let's get into the sheer audacity, maybe. The audacity of India's climate. We're talking extremes that are just jaw-dropping.
Oh, absolutely. It's astonishing. The temperature contrasts alone are immense. Think about summer in parts of the Rajasthan desert. The mercury can sizzle literally at 50 degrees Celsius.
50 degrees.
Now flip that. Picture a winter night way up in Dras in Jammu and Kashmir. It can plunge down to a bone-chilling minus 45 degrees Celsius.
Minus 45, that's a 95-degree swing.
Yeah.
In the same country.
Precisely. It's like a continent-sized tapestry woven with almost every climatic possibility. It really hammers home that India isn't just one climate. It's many, many climates all packed together.
And then you have places where the difference between day and night temperature is,
Wow.
well, barely noticeable.
Right. Down south, you look at the Andaman and Nicobar Islands. They offer that kind of equable climate. It's this constant, gentle warmth pretty much year-round. It just shows the sheer variety, doesn't it? Scorching hot, freezing cold, perpetually mild, all within India.
And the story continues with rain, with precipitation. Another tale of contrasts.
Definitely. You have Meghalaya receiving over 400 centimeters of rain annually. And Marsinram, within Meghalaya, famously holds the world record for the highest average rainfall. It's a land just drenched in life.
400 centimeters.
Yeah.
That's 4 meters of rain.
Exactly. But
Yeah.
then you go to regions like Ladakh, way up north, or western Rajasthan, and they get less than 10 centimeters a year.
Less than 10. So a land of incredible plenty and stark scarcity, often side by side. It's almost hard to comprehend.
It really is. It challenges your idea of what a single country's climate can be.
And how does this precipitation fall? Is it always, classic rain?
Not always. Up in the higher reaches of the Himalayas, it's primarily snowfall, adds another layer to the diversity. And the timing is interesting, too. Most of India gets its main life-giving rains between June and September. the monsoon.
Main event.
Right. But there's this curious exception, the Tamil Nadu coast down southeast. It gets a large chunk of its rain later in October, November.
Oh, interesting. Why then?
Well, that unique timing tells a fascinating story about shifting winds, which we'll definitely get into. It's all connected.
Okay, these dramatic swings, these stark contrasts, they can't just be random, can they? There have to be these big, powerful forces at play, like architects shaping it all.
You've hit the nail on the head. They aren't random at all. There are major controls orchestrating India's climate, beyond simple things like, say, soil type.
So what are these grand architects?
There are 6 key factors really in charge. You've got latitude, altitude, pressure, and surface winds. Then there's upper air circulation, distance from the sea, and ocean currents. Each one plays a critical role.
Let's break those down. Latitude first.
Okay, latitude. Think about the Tropic of Cancer. It literally cuts India almost perfectly in half. Runs from the Rana Kuch in the west, right across to Mizoram in the east. And this geographical line, it directly influences how temperature zones are distributed. It creates really distinct climates in the northern tropical half and the southern subtropical, almost tropical half.
And then looming large to the north, the Himalayas. They're not just stunning mountains, are they? They're absolutely critical for the climate.
Critical is an understatement. They're this colossal climatic barrier. Average height around 6,000 meters.
6,000 meters.
Yeah. And what they do is they prevent those bitterly cold, frigid winds from Central Asia from sweeping down into the subcontinent. This keeps the northern plains much warmer than other places at similar latitudes globally. And they also act as a rainmaker. They force those moisture-laden monsoon winds to rise, cool down, and then just shed their moisture as rain or snow.
So they act as a shield and a rain catcher.
Perfectly put. A mountain range that truly dictates the region's destiny.
Okay, let's talk about the sea. India has this massive coastline. How does being near or far from the water affect temperature?
This brings us to a really important concept. Continentality.
Continentality, okay.
It's basically the phenomenon where the further you get from the sea, the more extreme the weather conditions become. Very hot summers, very cold winters. Why? Because land heats up and cools down much, much faster than water does.
Right, water holds its temperature.
Exactly. So coastal areas like peninsular India, which is surrounded by sea on 3 sides, they experience much more moderate temperatures, less variation. It's like having a natural thermostat.
A natural air conditioner and heater.
Pretty much. You look at somewhere like Thiruvananthapuram, way down south, we have data showing it has this remarkably consistent temperature year-round. The range is tiny, maybe only 2.5 degrees Celsius difference between the average monthly highs and lows across the whole year.
Wow, that's incredibly stable. A real testament to the sea's power.
Absolutely. It moderates everything.
Okay, and then there's this invisible force you mentioned. A subtle twist affecting winds and currents. The Coriolis force. Sounds a bit mysterious.
It does sound a bit mysterious, but it's pure physics. The Coriolis force is what we call an apparent force. It's caused simply by the Earth spinning on its axis. And what's crucial for us is that it deflects moving objects like wind to the right in the northern hemisphere.
To the right.
And to the left in the southern hemisphere. This deflection, this little nudge, is absolutely fundamental for understanding global wind patterns, ocean currents, and crucially for our story, the mechanics of the Indian monsoon.
So the Earth's spin is literally bending the wind.
In effect, yes. It subtly nudges everything out of a perfectly straight path. Without it, weather systems would be completely different.
You also mentioned upper air circulation as a major control. What's that about?
Think of it like rivers of air high up in the atmosphere, jet streams, for example. These powerful, high-altitude winds steer weather systems across the globe. For India, there's a key player called the westerly jet stream. In winter, it flows south of the Himalayas and influences the weather over northern India, often steering those cyclonic disturbances we talked about.
The ones bringing winter rain, the Mahawat.
Exactly. Then in summer, this jet stream shifts north over the Tibetan Plateau. And that shift is crucial because it basically allows the warm, moist monsoon winds from the south to sweep in. It opens the door for the monsoon.
Wow. It's like this incredibly intricate clockwork, all these pieces interacting.
It really is. Latitude, altitude, the sea, the Earth's spin, high-level winds, they all dance together to create India's climate.
So India has this distinct rhythm, doesn't it? A cycle of seasons. We generally talk about 4 main ones, each with its own character, like acts in a grand annual play.
That's a great way to put it. It is a drama. Let's follow that progression, starting with the cooler part of the year.
All right, Act 1, the cold.
Right. The cold weather season. This generally runs from mid-November through to February. December and January, those are typically the coldest months, especially in the north. In the northern plains, you're looking at average temperatures between maybe 10 to 15 degrees Celsius. Generally warm days, but the nights can get quite crisp and cold. We saw Delhi, for instance, has an average January temperature around 14.4 degrees.
Okay. And the winds during this time?
The prevailing winds are the northeast trade winds. They blow from the land towards the sea. Because they're coming from the land, they're mostly dry. So this season is generally dry for most of the country.
But wait, wasn't there an exception? Tamil Nadu.
Exactly, you remembered. The Tamil Nadu coast actually picks up some moisture as these winds cross the Bay of Bengal briefly, so it gets some rainfall during this season. It's quite unique. And another key feature, especially for the northern plains, is that inflow of weak cyclonic disturbances.
The Mahawat again.
Yes, the Mahawat. Originating way out west over the Mediterranean Sea and Western Asia, they bring this really crucial winter rain, vital for the rabi crops like wheat. Meanwhile, down in peninsular India, thanks to that moderating sea influence we discussed,
Right.
there isn't really a well-defined cold season. It stays relatively mild.
So from that crisp, sometimes rainy cold, the pendulum swings completely. Act 2. The heat.
And how? The hot weather season, roughly March to May, temperatures start to climb and they can really soar. We mentioned Rajasthan hitting 50 degrees C potentially. Peninsular India stays relatively cooler, again, thanks to the sea. But north and central India, it gets intensely hot. And a defining, almost notorious feature of this season is the loo.
Ah, the loo. I've heard of that. Hot, dry winds.
Exactly. Strong, gusty, incredibly hot, and dry winds that blow during the daytime, particularly over north and northwestern India. They can be quite dangerous, actually. But this season also brings some localized, often dramatic, pre-monsoon thunderstorms.
Pre-monsoon. Like a preview.
Sort of. In West Bengal, they have something called Kal Baisakhi, violent winds, heavy rain, sometimes even hail. The name means calamity of the month of Baisakh. And further south, in Kerala and Karnataka, you get the mango showers.
Mango showers. That sounds much nicer.
It is. They're named because these early showers help the mangoes ripen, so they're generally welcomed.
Okay, so we've had the cold, the intense heat, and now the main event. The grand arrival, Act 3, the advancing monsoon. This is the big one, isn't it? The heartbeat.
This is absolutely it. The advancing monsoon, typically June to September. What happens is, by early June, the intense heating of the landmass India and interior Asia creates this massive area of low pressure, especially over northwestern India. It acts like a giant atmospheric vacuum cleaner, basically.
Sucking the air in?
Exactly. And this causes a complete reversal of the prevailing wind direction. Now, winds start blowing from the southwest, originating way down over the southern Indian Ocean. These are the southwest monsoon winds. They blow over vast stretches of warm ocean, picking up enormous amounts of moisture.
And then they hit land.
And they bring widespread, life-giving rainfall across pretty much the entire Indian mainland. They arrive with quite some force, moving at an average speed of about 30 kilometers per hour. The onset can be quite dramatic, sometimes called the burst of the monsoon.
And the rainfall amounts can be huge, right? Like the Western Ghats.
Oh, yes. The windward side, the western slopes of the Western Ghats, gets hammered. Very heavy rainfall, often more than 250 centimeters in the season. And as we mentioned, Mawsynram in Meghalaya, nestled in the Khasi Hills, holds the world record. Our data for nearby Shillong shows over 225 centimeters annually, most of it during the monsoon.
It's just incredible amounts of water. Does it rain everywhere equally, though?
No, not at all. There's a distinct pattern. For example, rainfall generally decreases as you move from east to west across the Ganga Valley. Kolkata gets more rain than Delhi during the monsoon. And importantly, the monsoon isn't just one long, continuous downpour for 4 months.
Ah, right. You mentioned breaks.
Exactly. It has breaks periods where it doesn't rain for several days or even weeks, interspersed with these wet spells. These breaks are often related to the movement of the monsoon trough, this low pressure zone. And another factor influencing the rain are tropical depressions. These often form over the Bay of Bengal.
Right.
And they move inland, bringing heavy rainfall spells, especially to central and northern India. They really determine the amount and distribution of the rain.
So it's powerful, it's essential, but it's also unpredictable.
Highly unpredictable. That's one of its defining characteristics. The monsoon is known for its uncertainties. Its arrival can be early or late. The amount of rain can vary wildly from year to year. This often leads to these contrasting, heartbreaking situations, devastating floods in one part of the country while another part faces severe drought, sometimes in the very same year.
Wow, that uncertainty must shape so much of life.
Absolutely. Agriculture, water management, the economy, everything is tied to the monsoon's whims. We see Mumbai, for example, hitting its peak rainfall in July, over 60 centimeters in that month alone in the data we looked at. That's the monsoon at its height.
Okay, so after the intensity of the advancing monsoon, things start to wind down. Act 4, the retreat. But it's not just a quiet exit, is it?
Not always quiet, no. The retreating or post-monsoon season, this is mainly October, November. What happens is the sun starts moving south, the land cools down, and that big low-pressure trough over the northern plains weakens and is gradually replaced by a high-pressure system. This signals the withdrawal, the retreat of the monsoon winds.
And does the weather change immediately?
It transitions. Early in this period, especially October, you often get what's called October heat. The sky's clear, but temperatures remain quite high, and the humidity is still high because the ground is moist. It can feel really oppressive.
Sticky and hot. Got it.
Yeah. Then, as November approaches, that low-pressure area that was over northwestern India effectively shifts. It gets transferred over to the Bay of Bengal. And this is where the drama can happen.
Cyclones.
Exactly. These shifting low-pressure systems, often originating near the Andaman Sea, can intensify into cyclonic depressions. These often move westwards and strike the eastern coasts of India, particularly the deltas of the Godavari, Krishna, and Kaveri rivers. They can bring very strong winds, heavy rain, and destructive storm surges.
So the retreat brings its own dangers, especially for the East Coast.
Definitely. And remember Tamil Nadu getting rain late. This is primarily when the Coromandel Coast gets the bulk of its annual rainfall, from these retreating monsoon winds picking up moisture over the bay, and especially from these depressions and cyclones. Chennai's data clearly shows this, with its highest monthly rainfall in October and November.
Wow. So the cycle completes. But each phase has its own distinct character, its own challenges, its own gifts.
Perfectly summarized. It's a continuous dynamic cycle that defines the year.
So we've gone through the mechanics, the seasons, the incredible extremes. But let's circle back. What does the monsoon truly mean for India? Beyond just the meteorology, what's its deeper significance?
I think the core truth, as our source material really emphasizes, is that pretty much everything, the Indian landscape itself, the animals, the plants, the entire agricultural calendar, and the very life of the people, including their festivals, their celebrations, it all revolves around this monsoon phenomenon.
It really binds the country together.
It absolutely binds the country. It provides that essential water needed to kickstart agricultural activities across vast areas. It's the lifeblood. Without it, life as it's known in much of India wouldn't be possible. Think about Monsoon's incredible abundance versus Leh's stark dryness, just 8.5 centimeters of precipitation a year in Leh, according to the data. That difference isn't just weather, it dictates entirely different ways of surviving and thriving.
And that variability. Areas with high rainfall are prone to floods, while those with low rainfall, like western Rajasthan and Ladakh, face the constant threat of drought.
Precisely. High variability often means high vulnerability. It's a constant dance with nature's extremes.
We also looked at some specific data from Table I in our sources. It really brought some of these points home, didn't it?
It did. It put concrete numbers on the concepts. We saw Leh with the lowest rainfall, just 8.5 centimeters, and Shillong near Monsoon with that staggering 225.3 centimeters. The difference is just immense.
And Chennai stood out.
Yes, Chennai getting its highest rainfall in October and November, perfectly illustrating that retreating monsoon pattern and the impact of those Bay of Bengal cyclones.
What about temperature ranges? Leh was extreme there too, right?
Absolutely. Leh's data showed a huge range from an average low of NX 8.5 degrees C to a high of 17.2 degrees C across the year. Very continental, very high altitude, over 3,500 meters. Contrast that with Thiruvananthapuram, down south near the equator. It had the most equable climate in the table. Minimal temperature variation, just 26.2 degrees to 28.7 degrees C range. That's the sea effect in action.
And Mumbai's peak rain in July showed the advancing monsoon clearly.
Right. And Nagpur was interesting too. Its average temperature actually dropped significantly from May, the peak of the hot season, into June, when the monsoon arrives. Despite June being summer, the rain brings that much needed relief.
It literally cools things down.
Yes. And Delhi's January average of 14.4 degrees C fits perfectly with the description of winter in the northern plains. The data really backed up the broader picture.
An incredible journey this has been, really digging into India's climate, from the basic definitions to the colossal influence of the Himalayas and this intricate, vital dance of the monsoon. It's so clear that this isn't just weather patterns. It feels like a living force, breathing life into an entire nation, shaping its land, its
Yeah.
people, its culture.
Indeed. That phrase, the monsoon phenomenon, truly binds the country. It really resonates. It influences everything, from the physical landscape right down to the timing of festivals. Understanding these deep patterns, these rhythms, it helps us appreciate the remarkable resilience, the adaptability that's just ingrained in India's way of life, constantly responding to nature's powerful pulse.
So for everyone listening, what does this all mean? Maybe next time you hear about rainfall figures or a heat wave hitting parts of India, perhaps you'll think a little differently. You might connect it back to these grand, often invisible forces we talked about: latitude, altitude, pressure systems, those crucial ocean currents, the spin of the Earth itself.
We really hope this deep dive encourages you to look at your own surroundings wherever you are with a bit more curiosity. How do your local weather patterns connect to these larger global systems? What stories do the clouds, the wind, the rain tell about the land you live on and how people have adapted to it?
And maybe, just maybe, a final thought to leave you with, something a bit provocative. Given the monsoon's inherent, almost defining uncertainties, delivering devastating floods in one region while another faces crippling drought, often in the same season, how does this constant push and pull, this annual drama of extremes, continue to shape India's innovation, its approach to agriculture, its water management, and really its entire future, especially in our rapidly changing global climate?
That's a powerful question to ponder. How does a nation so fundamentally tied to this unpredictable force navigate the future?
Something to think about.